Find the volume obtained by rotating the region between the graph of y equals 1/2 the sine squared on x squared and the x-axis, the region between these two. For x is between 0 and root pi. And we're going to rotate this about the y-axis. Now this isn't a graph that we can say we know the graph right away. This isn't a function that we know the graph of right away, but we can sort of figure it out. And so our first step is to get a good graph. You want to graph the region. And so when x is 0, you have to figure out what y is. So y would be 1/2 the sine of 0 squared. Sine of 0 is 0, so y would be 0. And if x is the square root of pi, then y would be 1/2 the sine of pi squared, but the sine of pi is 0 as well. So here y is 0. So we started 0, we ended 0, and then the question is, well, what does it look like in between? We can take some value to take a guess. If we have the square root of pi over 2, that'd be a good one to choose, where y then would be 1/2 the sine of pi over 2 quantity squared, and the sine of pi over 2 is 1, so this is y is 1/2. And it's going to be like a maximum. You know, it's going to grow like sine grows, and the fact that it squares changes the concavity of it, but it doesn't change the general shape. So if I was to sketch a quick graph, then we'd have the y-axis, we'd have the x-axis. At 0, we're 0. At the square root of pi, we're 0. In between, at the square root of pi over 2 somewhere, we're up to 1/2. Maybe that actually is somewhere over here. And so it should look something like that. The sine squared on x squared with a 1/2 in there. Okay, and we're going to revolve this around the y-axis. Alright, great. So what do? Well, we have to figure out which method to use. That's the next step. Decide the method we're going to use. Here are two accurate graphs. And so when we're deciding the method we use, we draw in rectangles. One that is parallel to the axis of rotation and one that is perpendicular to the axis of rotation. So here's one that's parallel to the axis of rotation. Rectangle. Here's a rectangle that's perpendicular to the axis of rotation. When you're parallel to the axis of rotation, then that's the shell method. When you're perpendicular to the axis of rotation, it's either disk or washer, and because there's this gap here, it's going to be washer. We're not flush up against the axis. If we're rotating around the x-axis, then it would be disk. So which one is better? Well, first let's decide which variable we're in. This rectangle starts at 0 and then moves to the square root of pi. So this one is in the variable x, while the other one would be in the variable y. That right there is enough to help you figure out which method to use. As you move this upward, we need to have everything in terms of y. We need x as a function of y. And the curve is 1/2 of sine squared on x squared. So not only we have to multiply by 2, we'd have to take a square root, then we'd have to take an arc sine, then another square root. Basically, no way. should we be doing this in y? We should be doing it in x. And so if that's the case, then we decided that shell was the method that we had to use. With shell, what we need is a radius and a height. Two things. The radius is the distance from the axis to the rectangle. This distance here. That distance happens to be the distance off of the y-axis. Okay. And that's called x. The distance off the y-axis is called x. Now the height is just how tall the rectangle is. And that's the function. 1/2 of the sine squared on x squared. Now the formula for volume when you're doing shell will be 2 pi times the integral from a to b of the radius times the height. Here's the radius, here's the height, and we're doing it in terms of x. What's the a, what's the b? Well, we're going to start this at 0 and end this at the square root of pi. And so that's our a and our b. And now we're ready for the calculation. Our volume is 2 pi times the integral from 0 to the square root of pi, 1/2 x sine squared on x squared. Okay, well, the 2 and the half can cancel and we get a pi. And we have to deal with the x times the sine squared on x squared. The key is that the inside function x squared has a degree 1 power higher than the outside function x. So that's a clue that we should start thinking about u substitution. If I let u be x squared, then du is twice x dx. Or that half of du is going to take the place of x dx. And so then this would become the sine of u, but not just the sine of u, the sine squared on u. And then there's my x dx, and I replace that with 1/2 of du. We'll still deal with the pi and the units, but I just want to find the antiderivative here and then go back. And so if you want, we could change the units here. When x is 0, then u is 0, and when x is the root of pi, then u is pi. So if you want, we can go ahead and put 0 and pi as limits here. Nothing wrong with that. Don't forget the pi that's on the outside though, and that'll be your volume. Let's go ahead and write it over here. That it's equal to pi times the integral from 0 to pi. Let's pull out the half, and then we'll have the sine squared on u du. Well, how do you integrate sine squared? You need an identity. Sine squared on u is not just the 1 minus cosine squared. That'd be trading sine squared for cosine squared. The sine squared on u is 1/2 of the quantity of 1 minus the cosine on twice u. That's the formula that we'll have to replace the integrand with. So we have a pi over 2, the integral from 0 to pi, and now 1/2 1 minus the cosine of twice u. Altogether, we're looking at pi over 4, and now we need to find the antiderivative of 1, and then antiderivative of cosine of twice u. Okay, we need to find the antiderivative here. We're at a point where we can do it now, so let's go ahead and do it. The antiderivative of 1 is u, with respect to u. What function has 1 as its derivative? It's u. Now this one's a little bit more difficult. The antiderivative of the cosine of twice x is the sine, you would think it'd be the sine of twice x, but there'd be an extra factor of 2, which you need to cancel by putting a half out there. And so we get 1/2 the sine of twice u as our antiderivative there. And we're going from 0 to pi. And don't forget about the pi over 4 on the outside. So we put a pi in and we get pi minus half the sine of twice pi. And then we get 0 minus half the sine of 0. These guys are just 0. We could have figured that out a different kind of way, but let's just leave it as it is. We integrated a full period of cosine twice u. We integrated a full period of it, and so we're going to get 0 for the area. Anyway, we end up with basically, sorry about that. We end up with all of this giving us pi, and then the pi over 4 on the outside. Final answer to this question is pi squared over 4.